Hello and welcome. Today we're going to lay the foundations for the rest of geometry. First, for this unit, we will define some vocabulary and symbols, starting with points. A point is defined to be an exact, dimensionless location in space, meaning it is zero-dimensional, only consisting of location. To name or write a point, we just write point and then the letter that represents it, for example, point B here. Next, a line, which is an infinitely long structure with no width, depth, or curvature. Basically, it extends forever, but only in two directions. And to name one, we use the symbol with arrows on top above either the line's letter or two letters of the points that are on the line. This works because every set of 2 points defines exactly one line, which is the line that passes through them both. Now a plane, which is defined to be a structure extending infinitely in both width and length, but no depth or curvature. These will often be depicted as rectangles like here, but in reality they stretch on infinitely and have no shape. Like points, there is no symbol for planes, so you can just write plane and then what you use to define it. Planes can be defined by either any 3 points for the same reason as a line and a point, or 2 lines. A line segment is defined as a portion of a line that is bounded by 2 distinct endpoints. Hopefully self-explanatory, but it is simply a segment of a line, and these can be named by either the letter that represents it or the 2 endpoints. Unlike a line, the 2 points used to define it cannot be anywhere on it, they must specifically be the endpoints. Similarly to a line, they have this bar symbol to denote them, which is just the same as the line symbol without the arrows. Next, a ray, which is a structure with one endpoint that it stretches indefinitely from in one direction. These can be named just like lines or line segments, with the endpoint and any other point on it. When naming a ray, the endpoint must come first, and the arrow symbol above it must be pointing to the right. Now we have the structure so important it needed 2 pages. An angle, defined as a structure formed by 2 lines, line segments, or rays that intersect. The angle symbol, used right here, is used to denote it. One way to name an angle is to simply write the letter that the angle is located at. When there are more than one angles at that point, though, you can instead use 3 letters. One is located on one of the lines or rays that make the angle, one on the point of the angle, and the other on the other line or ray, in that order. A few more things about angles. The point we have been discussing, where the angle is located, is called the vertex, and in this example, the vertex of the angle would be point A. Also, all angles can be grouped by their measure into 5 categories: acute or less than 90 degrees, right or exactly 90 degrees, obtuse or more than 90 but less than 180 degrees, straight meaning exactly 180 degrees, or lastly, reflex meaning more than 180 degrees. When we are referring to the measure of an angle, we must put an m before the symbol, so if we want to relate the measure of angle A, we would denote it like this. Last and probably least for the structures, we have the sides of an angle, which are the 2 raised or line segments that intersect to form the angle. You might notice that we aren't talking about lines here, because even if the angle was formed by a line or 2, it would get cut off for the purpose of being a side. Moving on to the second half of this video, we will discuss geometric relationships, starting with collinearity, which is a relation that 2 points will have if they are both on a line segment, or ray together. If 2 points do not share a defined line together, then they are non-collinear. For example, in the diagram to the left, the points A and C are collinear, but the points C and E are non-collinear. Another requirement we didn't cover earlier to name a plane is that the structures used to describe it must not be collinear, so that every structure adds new information. Coplanarity, similar to collinearity, describes 2 structures that lie on the same plane. In the diagram to the left, points E and B are coplanar, but points D and C are non-coplanar, and line M would be non-coplanar to line AB. Next, opposite rays. 2 rays are opposite to each other if they share the same endpoint and form a straight angle of 180 degrees. For example, in the diagram, the rays CB and CE would be opposite rays because the measure of angle BCE is 180 degrees, so it's a straight angle, and the rays share an endpoint of point C. However, the rays CB and CD are not opposite rays because we do not necessarily know that they meet at a straight angle. Something we didn't cover earlier when discussing the sides of an angle is that they have names. One will be the initial side and the other is called the terminal side. The initial side is the side that the rotation that created the angle started from. The terminal side is the side where the rotation ends or terminates. Typically, the initial side will be perfectly horizontal, but to be certain which is which, the terminal side is the side that the arrow points to. Lastly, we have intersections. An intersection is where multiple structures meet. Typically, an intersection will take the form of another structure of less dimensions. For example, in the diagram on the left, the intersection of line ij and plane P would be point G. And on the right diagram, plane Q intersects plane P at line M. And that's it. Now let's do some comprehension questions to help you remember. Pause to try them out. And here are some answers. We have a second page this time, but same deal. Pause now. And here are the rest of the answers. Thanks for watching. I hope you enjoyed and learned something. See you next time.